Hello everyone, I'm coming back with a new video on how to solve a linear system of equations, right? A system of linear equations where, we have a parametric solution. So we're going to take this big example right here, but I hope the calculations will not be like heavy. So let's write the augmented matrix, which is, 1, 3, okay, 8, 3, 8, and then we have 11, 2, 7, 18, 7, 19, and then we have 25, -2, -5, -14, -4, -12, and then we have -20, and finally 1, 2, 6, -1, 2, 11. All right, so we're going to do our best to get the reduce row echelon form, right? I think, by now you guys know how to do it. So we're going to take this one as our pivot. So we're going to rewrite the first row is 1, 3, 8, 3, 8, and then 11. Okay, now what you're going to do? You're going to do to get zeros under our pivot, we get the -2 R1 plus R2, which is what? Which is everybody is multiplied by -2, and we add them up. We get 0 here. -2 times 3 is -6 plus 7 is 1. So this one is welcome here. -2 times 3 is -16 plus 18 is 2. -2 times 3 is -6 plus 7 is 1. And -2 times 8 is -16 plus 9 is 3. 19 is 3. -2 times 11 is -22 plus 25 is 3. All right, that was good. So now we move to the next one. This one we just do 2R1 plus R3. Okay. So what you get? We get what? We get everybody's multiplied by 2 in the R1 and then we add it to R3. So we're going to be 0 here, of course. 2 times 3 is 6 plus -5 is 1. 2 times 8 is 16 plus -14 is 2. 2 times 3 is 6. 6 plus -4 is 2, right? And 2 times 8 is 16 plus -12 is 4. And then 2 times 11 is 22 plus -20 is 2. All right, that was good. And then we move to the last one, where we're going to do simply -R1 plus R4. We're just going to subtract the two rows. So 0 here, 2 minus 3 is -1. 6 minus 8 is -2. -1 minus 3 is -4. 2 minus 8 is -6. And then 11 minus 11 is 0. All right. So you got this one right here. So now we move, this one will be our pivot. As you can see, the column is a very nice column. So what we have, we're going to rewrite the row number 1. So 1, 3, 8, 3, 8, and then 11. Okay, 0, 1, 2, 1, 3, and then 3. Okay, now we're going to do -R2 plus R3. You get a 0 there. So what you get? It's just row number 3 minus row number 2. That's a 0. That's a 0. That's a 0 right here. That is a 1. That is a 1. And this is a -1. And then to get the -1 becomes 0. So we get R2 plus R4. R2 plus R4 will going to be 0 here, 0 here, 0 here. That's a -3, right? And that's a -3, 2, right? And then that's a +3. Okay. All right. So as you can see, now we move to our next pivot, which is this one right here. So we want to get a 0 under that one. So we're going to, okay, let's rewrite the other rows. It's 1, 3, 8, 3, 8, 11. I'm making to write all the steps because, for the sake of explaining, right? 1, 3, 3, 0, 0, 0, 1, 1, -1. And then we're just gonna 3 R3 or 3R3 plus R4, right? To get a 0. There, what you get? We get 0 here, 0 here, 0 here, and then these two happen to be zeros nicely, and then even the last one. So, okay. You see, from right now, some of you might say, okay, I'm ready to do my parametric things, but why not go until we get the row reduced echelon form, right? For now, we don't have the row reduced echelon form, which means, in our pivot columns, this one and this one right here, why not get 0 here, if possible, 0 here, and here, 0 here. So we should want to make the parameterization easier, right? Now you can stop right here and choose your parameters. By the way, the choice of the parameters, if all calculations are done correctly, the choice of the parameters does not change the solution. We can describe the same solution with different choice of parameters. But some choices of parameters will lead to easier calculations than others choices of parameters. Basically, here we have left with 5 variables, x1, x2, x3, x4, x5, and at the most we have 3 independent equations at the most, which means at least we will need about a couple of parameters, right? 2 of the variables might be set as parameters, okay? So, all right, so why not get 0 here? If you go to the fourth column and then second column, so we're going to do using the pivot. So we're going to do -3, or we're going to start with the other one. So why not get 0 here? In the fourth column, we're going to do, I have 0, 0, 0. Okay, this one is gone. The last column is 0, so I even don't have to use it again, right? This one is gone. I have what? I have 0, 0, 0, 1, 1, and then -1, right? And then to get 0 here, why not do negative R3 plus R2? So we're going to the first row minus the second row, right? So it's going to be 0 here, 1 here, 2 here. The second row minus the third row. Is that going to be 0? Right? That's going to be 2. And that's going to be 4. Okay. And here to make the 3 become 0, why not do -3 R3 plus R1? That's going to be 1 here, 3 here, 8 here. That's going to be 0 here, and then 3 times, -3 times 1 is -3, right? And then plus 8 is 5. So, and then -3 times -1 is +3, and plus 14. Okay, so again, we multiply the row number 3 by -3, and we added it to the row number 1, right? So we don't have the row reduced echelon form yet because, the pivot columns, which is this one, and this one, we need to have zeros on the top of the one. The only number that will not, that will not be 0 is the pivot itself. So which means we have one last stuff to do is here to make this one 0. So again, we will check. Eventually, you're gonna check if I did any calculation mistakes. It happens when we do a lot of arithmetics. We can do mistakes. So mistakes are part. We just make sure to do our best to avoid those mistakes. For instance, going over the calculations a second time if you have time to do it. When it comes to my grading, I focus more on the process, right? If somebody does a mistake, an honest mistake, of course, I will not give you the same grade as, somebody who did not. But if your process is right, I will not cross all what you did because of one mistake. Okay. I will, take into account that you had a correct process. All right. So now we're going to take care of this one to make it 0 right here. So we're going to do, that's going to be, um, see, that's right. So our 0, 0, 0, 1, 1, and here -1. So we have 0, 1, 2, 0, 2, 4. And then the last one is going to be -3, row number 2 plus row number 1. It's going to be 1 here, 0 here. You see, -3 times negative times 2 is -6 plus 8 is +2. That's going to be 0 here. And then -3 times 2 is -6. -6 plus 5 is -1. And here -3 times 4 is -12 plus 14 is +2. All right. So now, okay, now comes the choice is, how to write the parametric solution and which variables are easier to set as my parameters. You see here, if you look at the columns right here, we have the column of x1, x2, and x3. These are the pivot columns, right? So they are easier to solve for, right? Because of the raw echelon form, how it is. So I better choose, in this case right here, I better choose for my calculation to be easier to choose x3 and x5 as parameters in this case. The question is, what if someone else chose another set of parameters? It's okay, but but this one is a better choice, right? Way better choice than any other choice you could do in this case, right? So when it comes to calculation, for instance, the first one says x1, plus 2x3, right, minus x5 is equal to 2. As you can see here, x1 is easily said as -2x3 plus x5, right, plus 2, okay? And here, the second row says x2 plus 2x3 plus 2x5 equals 4. They say x2 equals to -2x3 minus 2x5 plus 4 again. So that was quick. And the last one says x4 plus x5 is equal to -1, which say x4 is equal to -x5 plus -1, you see? So if I choose x3 equal s and x5 is equal to t, what I get x1 is equal to -2s plus t plus 2. x2 is equal to -2s minus 2t plus 4. x4 is equal to -t minus 1, and then x3 equal s, and x4 is equal to t. I mean, x5 is equal to t. You see? So these sets of parameters of choice, this choice in this case, happens to be the easiest when it comes to calculations. Like I said, if you choose another set of parameters, the solution per se will not change. It's going to be the same solution, but with different parameterization. And that parameterization might be harder, right? For instance, from here, as soon as we get zeros, one row of zeros, somebody can say, okay, let me just choose randomly x3 equals this, x2 equals this. You can do it, but then it's gonna, you can have a way better, more complicated calculations to do. All right, so this was an example with you guys on how to write a set of solutions, parametric solutions, right? So you can expect to have that on the test, on the exam. It is fair. If you have a system, either you have a unique solution or you have, parametric solutions. It's not often that we don't have a solution, in this class. Okay, so be ready to be able to do that. Thank you very much.